This is section 5, Configuring Files with Templates. In this section, we'll explore the template function. We'll look at embedded Puppet, which is the language that we use to create templates. We'll talk about passing data to templates with template parameters, and we'll look at iteration and conditional logic in using template flow control. Exploring the template function. In this video, we'll talk about the purpose of templates, we'll do a brief template demo, and we'll look at using templates from our Puppet code. We've said before that 3 main things we do with Puppet are install programs, configure files, and set up services. We want to focus on the middle one of those, configuring files. We've already seen that we can have files embedded in our modules and use Puppet to deliver them to a system, place them in the correct directory to configure a piece of software. We also want to be able to manage the content of that file. We want to be able to change the configuration of software using parameters from our modules, and that's exactly what the template function is for. Templates allow us to build a configuration file using parameters in our modules in our classes. What we do is we create a configuration file with embedded Puppet. We start with the original file for the software that we're installing. We use its format, we use its terminology for everything, and then we embed small pieces of Puppet into that file that allow the server to then run that Puppet and populate the file based on some value in our parameters. That file is then sent down to the client, and then the client can see if the file has changed compared to what's already on the disk. It can update the file if necessary and refresh any dependent resources. Let's take a look at what that looks like. We'll start with a configuration file for a Postgres database service. Now you'll notice that this is the original postgresql.conf file that comes right out of the Postgres distribution. So we start with a file that looks exactly like what Postgres expects for its configuration. But if we scroll down all the way to take a look at line 59 here, what you'll see is that where we have a parameter like listen addresses, instead of actually providing a value, we provide a piece of embedded Puppet code. We use this angle bracket and the % as an indicator that everything in between, from there to the % angle bracket at the other side, everything there is embedded Puppet. And then with the equals, we tell the template function that the results of running this embedded Puppet code is then to be printed into the template file in exactly this location. So this equal sign means output whatever you find, whatever the result is of running this Puppet code. Now the actual Puppet code can be something as simple as just doing a variable lookup like we're doing in this case. So then the result of running that Puppet code, which is going to be the value of whatever is in that variable, will get printed into the file. We can go ahead and jump over to our target system to take a look at what that actually looks like. We'll move over to the directory where Postgres is installed, its data directory. You'll see there is a postgresql.conf file here. If we take a look at that file, we'll see where we have listen addresses that it sets it to the value of the actual variable that we had for our particular class. So what's populated into here is the value of that variable. Let's take a look at how we might change that. We'll jump back over to our code. We're going to use the hierarchy configuration we learned in our last section as a way to set the value of this PostgreSQL listen host parameter. So we'll provide that in this hierarchy data file, and we'll set it to a star, which for Postgres means listen on all addresses. Now that we've done that, if we hop back over and we run our Puppet configuration, our Puppet agent command, so we run Puppet agent-t, that will actually run Puppet against the server using that new configuration. It will run the template function, it will populate the template with this new data value. That will mean that there's an actual change to the file. You see the change there. As a result of that, it will update the file on the disk, and then because of the update, it will actually refresh the Postgres service so that it takes advantage of the new configuration. Now we can see that in two ways. We can take a look at it in the file here. So you see that the listen addresses has actually changed, that parameter has changed. We can also see that as a result of that, our Postgres server is now listening on all addresses instead of just listening on the local host. So that's how we can use embedded Puppet and parameters in classes to configure our files. The last piece of the demo to take a look at is what is the corresponding Puppet code that actually makes that happen. So let's take a look at our Postgres class. We'll take a look at the main class here, and if we scroll, what we'll see is that we have a file here. You can see we're using the file resource type within Puppet, and you'll notice that this is just a normal file resource type, just telling Puppet to put a file on the remote system. The only thing that's special about it is we use this content parameter and this EPP function. And this EPP function tells it we have an embedded Puppet file. We'd like you to process that with the template function, go through that file, run the embedded Puppet code, and then whatever is produced, whatever comes out of that as the result, that's going to be the content of the file on the remote system. So that's how it all fits together. We have this file resource type. We use the EPP function to process the template. The template contains embedded Puppet code. The embedded Puppet code pulls values from variables. The result of all of that is that we get exactly the right content onto the remote system. That concludes our look at the template function, our exploration.